for a long time we called that a word problem. So that's kind of really what we're looking at. And it's really important that we start out understanding some words. Now, we're writing inequality, so we're going to have a choice of either less than or greater than, or less than or equal to, or greater than or equal to. That's what we're going to have to pick. But what I've discovered is sometimes in the wording is more difficult for us than anything else. Definitely more difficult than the math. And one of the things that I do to help me figure out what to do is I kind of put it in a real world sort of situation. For example, I want to know what kind of inequality sign do I use for the phrase at least? Do I use a less than or a greater than, or less than or equal to, or greater than or equal to? Which one of those do I use that phrase at least? And what I will do is I will say I have, and I'll use these words, at least $50. Think about that. I have at least $50. Now, what does that mean? Well, that means a couple things. First of all, it means I have $50, or I could have more than $50, couldn't I? So if I'm talking about at least, then I know that if I have at least $50, so it could be equal to $50, or I could have more than that, so I'd have to say, well, it's greater than or equal to. One of the things that we run into, folks they'll see the word least, and they'll think less than, but it's not that at all. When I say I have at least, I'm saying I have an equal amount or more. Well, what if I'm talking about at most? Let's say I have at most $50. Then that means it could be equal to $50, right? You need to write this down if you're not. Or I could have less than that. Well, what about if I use the word below? And this list is not an inclusive list by any stretch of the imagination. What if I said I have below $50? And that means I don't have 50. It's not equal to, but I've got less. Well, I can't use $50 for the next one because that's taller. But I might say, well, I am taller than 5 feet. Well, I'm not equal to 5 feet if I'm taller than 5 feet, but I'm greater than 5 feet. It could be 6 feet, 7 feet, 10 feet, which would be really tall if I was that. Look at the next one. Again, we just want to determine what inequality sign to associate with this word. If I say I have under $50, then I would have to have less than $50. It's not equal. When I say I have under $50, I don't have $50. I have under that. Or if I have above $50. Again, not equal, but I know I've got more or greater than. What if I said today I started at $50 and I made more money? So I started at. Well, that would be started. It could be equal to or it could be greater as I accumulate more in the course of the day. Sometimes the wording determines whether we're going to write less than or greater than. So you've got to read the complete sentence. Well, if I say I have up to, I've spent up to $50, or you could spend up to $50. Well, I could spend 50, or I could spend anywhere underneath that 50 amount or less than. And so when I say up to is less than, I think because we use the word up to, we're thinking, we tend to sometimes not understand what it's saying, and we want to say greater than when it actually has to be less than or equal to. It's going to be really important as we look at some problems today. Well, we're going to look at 3 problems in IXL, and we are going to talk about how do we write those in terms of a inequality. How do we model that? So I put up on the screen in front of you a problem. And so here's the problem. The problem says that Kensington High School softball coach is purchasing equipment for her team. And she has a budget of at most $640. So the first thing I'm going to write down is at most $640. That's her budget. Now think of that. If I say at most, she could spend $640, but we're talking about a budget here. So we can't spend more than our budget. We're not allowed to do that. So at most I could spend $640, but I could spend less. That also says that a case of softballs has a price of $35. And it says a bat has a price of $32, and it goes on to define the variables for us. It says that X is the number of cases of softballs and Y is equal to the number of bats. And remember, the case of softballs cost $35 each. Going back up to the problem for a second. And the bat has a price of $32 each. So here's what we want to do. We will take the information and I've, like I said, I want you to write it down. So I've written it down. And I've just really condensed it down to the most important thing. We can spend at most $640. And that X is the number of cases of softballs, and each case costs $35, and Y is the number of bats, and each bat costs $32. And we're going to buy these for our school team. That's the point. But we can't spend more than $640. It's our budget. So we could spend exactly $640. We could do that. But we can't spend more. We could also spend less. So when I say at most $640, I know I'm going to use a less than or equal to type inequality. So for every bat I buy, then it's $35 times X. Or not bat, but excuse me, softball. For every case of softballs I buy, each case costs $35. So if I buy 2, it's 35 times 2, or 35 times 3 if I buy 3. Plus, for each bat I buy, it's going to cost me $32, so it's 32 times Y. Now, what I want to know is what combination of cases of softballs and bats will be less than or equal to 640. So here's the deal. At this point, I was just asked to pick, in the problem, if you remember, which one is the correct inequality. I don't have to go any farther than that, but I will tell you, I do have to put some things on pencil and paper to figure it out. So what I'm looking for there is 35x plus 32y is less than or equal to 640. And what I've noticed is that's my very first choice. It wouldn't be this choice because that's greater than. It wouldn't be this choice that's less than. That's greater than or equal to. I've got to make sure that it's the one that says less than or equal to. So I'll submit that. Sure enough, that's right. Let's look at another word problem, a little different one, okay? This one says that Emmett is playing games at an arcade, okay? Now, the arcade where the machines, they take tokens. They don't take quarters. And he can afford to buy up to 33 tokens. So he can buy up to 33 tokens. So he can afford to buy up to 33 tokens, and a skee ball requires 1 token. So it says down in our problem, X is the number of skee ball games. And that's 1 token. So I'm just writing that information down from the problem. And Y is the number of pinball games. And it takes 3 tokens for those. All right, so I think I've got all the information from the problem that I need. And so we're looking at this second problem, buy up to 33 tokens. So he can purchase up to 33. It means that he can buy an equal amount to 33, but he can't buy any more than 33. So he'd have to choose less than. So what I want to do is actually create an inequality that represents this situation. So I know that the skee ball game costs 1 token. Pinball games cost 3 tokens. So it's going to be 1x plus 3y because a skee ball game costs 1 token. Pinball game costs 3 tokens. And I know I can't get any more tokens than 33. I can get, any amount less than 33. And I can get equal to amount of 33, but I can't get more. Now, one of the things I'll point out to you, when we go to write our equation, we don't have to write the 1x. We know that already. We know we can write that as just x plus 3y is less than or equal to 33. So if I go back to IXL, what I'm going to have to do is put in that amount there. All right, so it's x plus 3y. And that is less than or equal to, so I have to choose this one, 33. So I've created an inequality. I'm putting it in. It's going to tell me I've got it right. Now, one of the things I want you to do, I'm going to tank this one on purpose. I'm just going to write in x. I hope you understand that IXL is there to help you. We've got the problem, what I've entered. Then they solve it for you and tell you how to do it, along with explanations on why that we chose less than or equal to. We'll look at one more problem. Mrs. Lopez is making her special cantaloupe and honeydew salad for a school banquet and doesn't want to spend more than $29 at the supermarket. So she doesn't want to spend more than that. So she could spend $29, but she can't spend more than that. So the first thing I'll write down is can't spend more than $29. Now, currently, cantaloupes cost $2 and honeydew costs $3. X equals the number of cantaloupes. And Y equals the number of honeydews. Remember that the cantaloupes cost $2 and the honeydew $3. So taking that information, we need to write an inequality. So I just jot down, I can't spend more than $29. X is the number of cantaloupes, and they cost $2 each. And Y is the number of honeydews, and they cost $3 each. So if I can't spend more than $29, I could spend $29. Or I could spend 28 or 27, so I could spend less than, but I can't spend 30 because I don't have that much money. So when I go to write this and model this inequality, I'm going to model it by saying, well, $2 times the number of cantaloupes, so that's 2x plus 3y is less than or equal to, and I can't spend more than $29. So just taking the information I've gotten there, I've been able to write an inequality. I need to enter that right quick. So that's pretty simple. It's just 2x plus 3y. Remember, it has to be the correct symbol here. That's the thing that will mess us up most if we pick the wrong symbol. It's less than or equal to 29, and sure enough, that's correct. All right, so we have an understanding now, a beginning of creating a inequality to model a real life situation.